Hello and welcome to Crafted Contraptions. In this video, I'm going to show you how I made a motorized Captain America shield.
This year I went to PAX East, a gaming convention, and for my first cosplay I went as the first Avenger, Captain America. But I didn't want to make just any shield. I wanted to make a shield that actually moved. And for my first video, I'm going to show you how. To make the top of the shield, I found a template online I cut up into parts, and then I transferred those onto 2 sheets of craft foam that I glued together. Next, I had to find the right angle for it to open and close. I measured it to be around 33 degrees. I designed the base of it on a program online called Tinkercad. This site will let me save my design to an STL file. Then I took that STL file to astroprint.com. Astroprint will allow me to take my STL file and slice it into a G-code. Using the G-code, I printed it out on my Ender 3 Pro 3D printer. I used PLA filament and I printed it out at 220 degrees.
And here's a look under the hood. The 2 top panels will be connected to these sections right here. The whole contraption is controlled by this one switch. It's a 3-position switch with forward, off, and backwards. The whole mechanism is controlled by 2 of these small servo motors. The switch will send power from the 2 AA batteries over to the 2 servos. I have one here to control the gears that will open and close the flaps, and one up top that will connect to a rack and pinion system that will move the top forwards and backwards. Here is a close-up view of the mechanism. The servo is connected to the gear with an arm. And the one switch connects both servos. Next, I'm going to show you how I wire up these switches. These are 3-position DP-DT switches with 1 off in the middle and 2 on. There are 6 pins on these. You'll have to wire them like this. You'll have to solder a small wire from this pin over to this one, and another small wire from this one over to here. Next, you'll solder 2 wires from here, the middle ones, to the positive and negative ends of your battery. Then you'll have to solder 2 wires on the ends that will connect to your servo. This is the inside of a servo motor. Usually you can control it with an Arduino. It would come in through here, connect to this chip, and then the chip would control how the motor functions. What I did was bypass all that and put power directly to the motor. All I needed the motor to do was go forward and backwards. I didn't need to control by how many degrees.